Hello, my name is Nick Nikiforakis. I hope you're not too tired. I'm a PhD student in Belgium. I'm doing low-level security research for languages such as C and C++. And sometimes I like to poke on web stuff, and this is one of these times. So the title of my talk is Alice Shares, Eve Reads, Enumerating File Hosting Services. And for those of you that don't know, file hosting services are services on which are usually accessible through a website, and users can go, upload their files, and then share the links with other users. So the outline of my talk is more or less this. I'll talk a little bit about the cloud, what it is. I'll be a bit more specific about file hosting services, how they work, how they generate the tokens that they bind with files that the user uploads, and the privacy issues behind these services. We'll talk about the possibility of enumerating them, and that it's actually quite easy. We'll see the results and how these results relate to security issues, and then we'll conclude. So, I'm guessing you've all heard of the cloud. You know, it's the coolest thing that people do today. The cloud is very good, and everyone is interested in it, and in the last couple of years, all sorts of companies have started providing things on the cloud. So you have storage on the cloud, you have software as a service on the cloud, you have bandwidth on the cloud, you have networking on the cloud, everything is on the cloud. And you should be able to recognize some of these logos like Akamai, which is a load balancer for popular websites, RapidShare, SendSpace, File Factory, which are file hosting services, and we'll look at them with more detail, Amazon Web Services, and so on. So essentially what it is shared resources on demand. It's great, you know, for startup companies that just started. They have this cool idea, but they really are not interested in investing tons of money in buying hardware, you know, buying their own data storage centers, buying their own multi-cores. No, they just want to employ their idea and see if it works and get money out of that. So the cloud is essentially resources that are shared among many users. And they have this pay-as-you-go style. So you sign up for their service, and if you use a little bit, you'll pay a little bit. If you use more, you'll pay more. So it's really great for startups, and no storage needed, no lineup, you know, no ADSL, no big lines coming at your place. But it's not really that good for private data, because once you lose control of your data, once you send them away to the internet, you're not really sure what happens then. You know, you just hope that they are taking care of your data, that they are backing them up, that they are keeping them secure, that they're keeping them confidential. And these are all real problems. So we already have some incidents. For example, data losses. In 2007, Amazon's Elastic Cloud just announced that to several customers that, sorry, we lost your application data. And you know, the explanation was that there was some programming error, and we really are not to blame because we are beta. And then in 2009, even worse, you have Microsoft, who is operating T-Mobile Sidekick, just lost all sorts of data of mobile subscribers, such as SMSs, calendars, pictures, contact books, what have you. And privacy related, these are not real incidents, but this is kind of a landmark of where we are going. You have Google that wants you to put everything on the cloud, nothing on your hard disk. And they even have this printing service, which they have on their offices, and every document that you will print will go through their office and then to a desktop, which means just, you know, free data for everyone. So file hosting services, I've dubbed it as cloud storage for the masses, because it's been out there for at least 5 years, starting with RapidShare, and people use it without really thinking about it. So they're also called one-click hosting, although you need at least 4 clicks in order to upload a file. They're operated mainly on anonymous access. So, you know, you just go to the website, you upload a file, you get a link, and you share that link with your friends. And they're used both for sharing public and private files. And they have been a great success because they fulfill a basic need that users have, and that is the need to share. And before them, you had other means to share, such as peer-to-peer networks. But these networks provided this binary idea of sharing. You shared your files either with everyone or with no one. You couldn't share it with just a couple of people or with just a person. You couldn't share it just with your spouse, just with your friends. You had to share it with everyone that was connected on Kazaa, everyone that was connected on LimeWire, everyone that was connected on BitTorrent. So most of you already know this, but this is more or less a helicopter view of how FHS work. You just go to their website, you use their web interface, no need to download drivers, services, and so on. You choose your file, you upload it. Internally, the service puts it somewhere on its cloud, you're not interested where, and it creates a token, it binds it to the file, it assigns it to the file, and it returns this token to the user in a URL form. And depending on whether the files are private or public, what happens with that, with the link differs. So if it's meant to be public, so if it's a movie, if it's MP3s, if it's something pirated or not, people post these links on websites, they post them on forums, they post them on their social profiles, they generally post them wherever they can. If it's private, then they send them through using a one-to-one link, such as email, IM, postal pigeons, it doesn't matter, just one-to-one. So privacy here is really very simple. Since most of them are based in anonymous access, they cannot give you privacy, they cannot protect your files based on your account. So what they do is they do security through obscurity. They just generate tokens, and they are advertising that their services are not searchable. So unless someone gave you, a URL to a file, you cannot download that file. And this is what I want to challenge today, that this is not true. And we'll see how. So for the purposes of this conference, I created a dummy file called AthCon.zip. I chose 8 popular file hosting services from Google, and I uploaded the file twice. So in the first column, I have dubbed them, because I don't want you to go and hack them, as FHS1 to FHS8, meaning file hosting service 1 to 8. And then you have the first upload and the second upload. And if we take them, in turn, let's see the first one. You can see that the 6 digits, 3, 7, 6, 5, 6, 7, are the same. And if you upload the third file, you will see that they're actually sequential. And the reason why they are so far apart is because the service is so popular that in the few seconds that it took me to upload a file and then upload it again, at least 100 people uploaded other files and got intermediate IDs. If we go to the second one, it doesn't look sequential, but it really is. They just have a shorter identifier by using also characters instead of just numbers. 3, 4, 5, the same, sequential tokens. And then you have 6 and 7, which appears to be random, and I haven't researched more in these because, well, I didn't need to. And the last one is just a plain silly one, that you just, the service just drops the extension of the file, saves it as what's remained, and if a file already exists, with that file name, it just puts an underscore and an incremental number. So your mind should already be racing that something is wrong with the first 5 and the last one. And some people will think at this point that, okay, you have sequential, IDs, but look, there are file names in most of them, so you cannot access them, right? And I'm saying wrong, because in reality, only the first file hosting service requires the file name in the request. All the other ones just put it there for indexing purposes, because they know that most people upload files in order to share them, to put them on websites and such. They're counting on this. So when you search in Google for AthCon.zip, you will find it and you will go to the file hosting service, but they're actually not requiring it in the GET request to get the file. So you can get files just by providing sequential numbers. And this can be generalized as predictability. If the tokens that are assigned by file hosting services are predictable, then the attacker can start from a valid token and then start predicting other valid tokens that he shouldn't have access to. And this can give you access to tens of millions of files. And in order to do a proof of concept, we chose FHS2 and 3 from the previous board. And we started with, I uploaded a file, this was a valid ID, I subtracted 1, and guess what, it was a valid ID. I subtracted 1, and it was another valid ID. And this is in the order of billions. FHS3 is the same. Just create an algorithm that, instead of just subtracting 1, you're doing some going down characters, and it's still valid. And you can see that it is 18 because you have 10 numbers and 8 characters in the power of 7. So you have an address space of more than 600 million files waiting for you to download them without having original access to them. And yeah, we just started enumerating them. We created just 2-digit source code programs in Python. We installed them on several IP addresses. And we put this random delay between each request so that we wouldn't get blacklisted. And because these services are so popular, our requests were interleaved with tens of legitimate requests, so we could operate for days without getting blacklisted or without getting any complaints. So using this method and this delay, you can get from one IP 8,640 records per day per service. So using the two file hosting services that, FHS2 and FHS3, with your home computer, with your ADSL connection, you can get access to more than 16,000 file records per day. And the interesting thing about it, the convenient for us, is that all of the services provide a file name and a file size before downloading the file. So you can just write down the file extension, the file name, and the size, and then you can just download whichever ones you think they are sensitive and whichever ones you actually want. So on this slide and the next one, I'm just having a sneak peek of the output. In the first column, you can see the decreasing tokens. The second column is the file name with the extension, and the last one is the size. And while you can find many interesting things, we're not really interested in the public stuff. This is just pirated crap. You can find it using Google already. But what we're interested is in private things that people shared using one-to-one emails and IMs, and they were not meant for them to be public. They were not meant for us to access them. So I have highlighted the second to last and the last one, and you can see that we're talking about a document and a JPEG. And most of you will realize that the JPEG starts with DSC, which is the automatic prefix that digital Sony cameras put on their pictures. So what it is, it's someone took a picture of his family, his spouse, whatever, shared it with whoever, and we got access to it. We shouldn't have. FHS3, the same, and now we're getting access to spreadsheets instead of just JPEGs. So we're talking about hundreds of thousands or even millions of files, and it's just too much data in order to go through them, just by hand. So we decided that we need an automatic thing, and we just thought of this simple idea. If a user means for a file to be public, he will just upload it and then post this URL in some forum, in some website, in some whatever. So if you search for that file name, you will find it. You will get search results. But if you search for it and you get 0, it means that it is private. And this is what we do. We chose this sexy keyword, automatic privacy classification engine, and for all of our records, we're just querying a search engine and checking the search results. And if the search results are 0, it means that the file is private. So we started doing it with Google. They quickly blocked us. And we used Yahoo, which provided a search API, and they gave us up to 5,000 requests per day. So getting access per IP of 16,000 files and being possible to enumerate 5,000 of them per day. So from when we stopped the experiment, we had about 400,000 records of files. So from them, we removed the ones that we knew that they were crap. So we removed MP3s, we removed .rars, we removed .exes, and things like that. And from those, the rest, we just kept on feeding them in our automatic classification engine. And we found out that 1 in 5 files were private, in the sense that they returned no search results. And what were these files? They were pictures, as in the one I showed you earlier. They were documents. They were spreadsheets. They were PHP pages. People back up their website by uploading PHP, the code, to file hosting services. And even worse, they then upload the dump from the MySQL. So guess what? Passwords, tables, organization, the whole thing is waiting for people, to access it. And in order to actually, so before that, we did also this classification of the top 10 private file types. So you can see that we have a lot of zips, and then you're going down to JPEGs, AVIs, PDFs, and so on. And in order to find out if what we downloaded was actually private, we just chose the first 100 records from each file type, and we automatically downloaded them, we manually inspected them. And we found many, many things, of which these are the most memorable. So we found bank statements, transactions, bank accounts, things. Okay, I'm finishing. We found company budgets, how much money they planning to spend on 2010, and how much money John Doe gets. Huge lists of phones, names, emails, dates of birth, everything in there. We found a death certificate that we were not expecting to find. We found a service manual for a photo printer with administrative username and password, something that doesn't go out in public. And this is the worst thing that should make you feel uneasy. We found doctor-prescribed notes from a psychiatrist who did a checkup on kids with mental issues. And, you know, they're recording them on tape, and once they're done, they're sending them to this transcribing agency, and they are typing them in the computer, and they're sending back documents containing the notes of the doctor. And guess what kind of, how this service send it back the documents. They send them using a file hosting service. So we're talking about name of the kid, disease of the kid, what medication he's getting, where does he live, what's the name of the doctor. This is as sensitive as it gets, and it is just waiting there, it's up for grabs. So, if you don't already know, what can you do with this data? You can have identity theft. If you have dates of birth, if you have emails, phones, addresses, you can just use them and do whatever you want. You can have scamming. If I call you on your phone and I know that your kid suffers from A and B, and I know what medication it gets, I can convince you to do anything, no problem. You can have server attacks. If I know how your PHP page works, if I know your SQL dump, I can just log in as admin, no problem. I don't have to hack anymore. You can have corporate espionage. Company A monitoring what company B exchanges. If employees exchange data using file hosting services, they can just start enumerating and getting access to all these files. And blackmailing, threatening someone to put his pictures online unless they pay you money or do whatever. And this is the peak that, let's say that someone in the audience has a file hosting service and says, oh damn, we're vulnerable, let's fix it. And they start generating random tokens from tomorrow. What happens with the millions of files that are out there that are already bound to sequential IDs? Their owners cannot be contacted because most of the services are anonymous. And, the dilemma for the file hosting services is either to delete millions of files and, take the wrath of your customers, or keep them and just be silent about it. And I can put my money on the second one, but that is what companies will do. So this brings me towards the end, and as I said, the file hosting services are really legitimately useful, and if you must use them, choose one that generates at least tokens that appear random to you. So upload 2 or 3 dummy files and check the tokens, and if they appear random, then it's good enough. And always, always password protect your sensitive data. You're already sending an email to your friends containing the link, to your file. You might as well add the password to that file. And then some services provide you with a link that you can delete the file from their cloud once you're done. So use that link and delete your file. And just a conclusion, most file hosting services are insecure, 5 out of 8. You can get from maximum results for minimal effort. I mean, less than 1 hour of coding and just 1 IP address with behind an ADSL line. And this is not easily solvable for existing file hosting services. And thank you for your time. I will take questions and comments now. Are there any questions? Yes?
The IDs are cookie-run.
Yes. Well, if your ID is long enough, so if it's 10 characters and you use a good randomized algorithm, you see it using the time and the file name, you can get something quite good. So if it's 10 characters wide, I'm thinking you're good. The problem is with all the existing services that cannot really switch to random anymore. Yes. Mm-hmm. Let's say 100. Yes and no. So if it's truly random, it won't be, because it won't matter how many files there will be. And Another thing is that if you start querying the service really fast, they will block you. And this is, I burned at least 1 or 2 public IP addresses before learning that lesson, that you must be slow about it. So just, you know, it's out there and you can just get millions of files. Yes? Yes, of course you will not get, you maybe try 100 times to get 1 file, but you can still get it. Yes, I agree. And this makes the attack even more possible. You can actually attack more file hosting services than the ones that are described.
Okay, thank you very much. Unfortunately, we can't take any more questions because we have to press on with the schedule. So the next speaker is Andreas Venieres, talking about authorization attacks using session hijacking. Thank you very much, Nick.